All right, so welcome to the video. So continuation from like terms, I guess, to polynomials. I will provide a link above. If you haven't watched the like terms video, it's worth watching. If you understand like terms, great. So what are these polynomials? Basically, the first thing that you kind of should know is whenever you're working with all of these different terms that have unknowns, you kind of run into three things. You run into monomials, mono meaning one, binomials, which is bi, which meaning two, and then poly, which means many. So in this case, what I have done is I have actually set up numerous examples of polynomials, and we're going to walk through them and we're going to collect all the different like terms and add them up and subtract them as we go along. So the first one that you have, okay, so in terms of a polynomial, notice that we actually have four terms. So remember that when you are working with various terms, they are separated by additions and subtractions. Now, if you throw in brackets, it makes things a little bit different, but if you remove the brackets, then all you're looking for is just additions and subtractions. And now the key thing is we want to be able to collect like terms, and those like terms, so they have to have the same variables and exponents on each of those particular terms. Okay, so let's get started. So what I'll do is I'm going to kind of cut these out and solve them one by one, and you can take the ones that you want to look at and see how these polynomials work. So for example, so here is the first one that we have, which is 3x minus y plus 14x minus 3y. So we have four different terms within here, and I notice right away, so here, both of these two terms, so the coefficients are different, but the unknowns are the same. Okay, they have the same exponent in this case. So I can nicely capture these and collect the like terms right there. And what that's going to be is, so 3 plus that 14, which becomes 17, the variable stays the same. All right, so that's x. Now, the other ones that I can collect, so notice that you have a y and then a 3y, but be careful because of the signs. So we have negative y and then negative 3y, or subtracting 3y. So that's going to be, so negative 4 or minus 4y. And that would be the collection of like terms. Now, this is now a binomial because it has two terms. And this is as far as we can take it because we have no idea what x or y is. Now, if we knew, then obviously we could solve the whole thing and find out what our answer is, but we do not know. Okay, so that's the first example that you have in collecting these like terms with a polynomial. Here is a second one. So this one right here. So let me capture this one and let's work through that example. So let's paste it up. Okay, so within here, so we have in brackets, okay, so negative x cubed plus 3xy, and then adding to another, so 9x cubed minus z or z. So in this case, what I like to do is I simply just will remove the brackets because they're kind of unnecessary, but when you're adding and subtracting polynomials, you often do run into questions like this. So for instance, I can completely rewrite this as negative x cubed plus 3xy, removing those brackets entirely. There's nothing to do. And now I can be adding. So now those brackets also, there is nothing really to distribute within here. So we have a polynomial of this case. So we have four different terms. So again, so remember terms separated by additions and subtractions here. And now what we're looking for is within these terms to see if we can collect any of them. So I kind of right away notice, so we have an x cubed here and an x cubed here within these terms. So we can definitely collect these. So we have, so this is a negative 1, okay, in front, okay, so plus the 9 which is right here. So that's going to be 8x cubed. Now, unfortunately, I can't do anything with this xy and this z or this z. I can't collect it anywhere else. And when that happens, all you can do is you can just simply leave them. So now we have a polynomial left in simplified form with 3 different terms, and that's as far as we can take that one. Okay, so that's the second example. So let me kind of clean this up a little bit here. And let's take our next example that we have. Okay, so that will be, okay, so this one is rather long. That's okay. So I'm going to grab this one. And what's nice about this example is it does actually introduce that you have coefficients which are decimals, and that can happen. When you're just starting, typically within kind of grade 9-ish or something of that nature, you're only working always with integers as your coefficients. Now, that's not always true, okay? Because as you keep going, you know, you can certainly have coefficients which are decimals or even fractions, and we'll do one of those as well. So here is this next example. So let me paste it up. So we have that. There are no brackets, so all I'm going to look for is just to see if I can collect some like terms. All right. So now, with regards to these like terms, what I have, okay, so here, what I'm going to do is I'm going to, okay, so I have z squared, okay, so not the second one, third, okay, here's another z squared, so I can actually collect these two. So notice I have 1.4 as my coefficient, and then I have -2. So I would have to do that, okay, so you can either write it on the side. I don't know if you're allowed to use calculators or not, you can do that, but that's something that you should be able to do. Okay, so within, so this is actually -0.6 z squared, and that's because the 1.4 minus the 2. All right, now is there anything else that I can collect? Yes, I can. So here is actually xz here and an xz here. So I can collect those. Again, my coefficients right here. So they're actually positive, and when you add them up, so that's going to be 2.3 xz. So now that's out of the way, and that only leaves us actually the terms which have no unknowns. They're just numbers. So numbers we can just go ahead and do. So I have 1.1 minus 3.2. So be careful. Okay, so when you're doing this, this is going to be -2.1. Okay, because that's what that is. So that's our example number 3. So it's a polynomial again. It has 3 terms in this case. So term 1, term 2, and term 3. And with that, we can't really do anything else. All right. So let's take a look. Okay, so at another example, here is example number 4. So let me copy this down. Okay, so the more examples you see, I guess kind of the better, and hopefully, you know, you slowly get a gist of how it works. So again, so I have no brackets, nothing really to do except try to see if I can collect some like terms. I right away, okay, see right here. So notice I have just a number here and just a number right here. So this I can very quickly collect. So this is going to be +3. So that's from -2 plus 5. Now anything else, the xy right here. Oh, we have an xy right here. So we can certainly collect these. So we have 14 as my coefficient plus 5. So together it's going to be 19. So this is xy. So that's what I have right there. And then I have this lonely, so -3y. I can't really do anything else with that because I do not have any like terms with that. And that completes this particular example. It's as far as we can go. All right, so let's take a look. So I'm going to go up here. Oh, now it's something that not a lot of students like to do is working with coefficients that are actually fractions. So if I'm going to paste this in here, I'll blow it up a little bit for us. Okay. So if we have something of this nature, it doesn't change in terms of trying to collect like terms. The only thing is it's annoying because we have fractions, right? Now these fractions aren't that bad. They're not always this nice, but when you do have fractions, you actually have to know how to do the fractions. All right, so here, let's see collecting like terms. So I have x squared. Oh, here's an x squared right here. So I can collect these two. So I have a half plus 5/6. So notice again, so I can create a common denominator. I'm going to create a common denominator of 6 because a half is actually 3/6. And notice this is going to be 5/6 from right here. So when you're adding up together, so this becomes 8/6, or in reduced form, 4/3. And it's an improper fraction. And in this case, you don't really change it back to a mixed number because we do have terms with some unknowns. So what I will do is this is going to be 4/3 x squared. And that's coming from that. Now, are there any other? Yep. So we have a y right here and a y right here. So this one's a little bit easier. So notice my coefficients, so -3/4, and the coefficient right here is a +1. So that I can do. Okay, so right away, so remember that 1 is just 4/4 if you wanted to have the same denominator, and then -3 + 4. So here we have 1/4. So that comes from this evaluation, and then we have our y. And anything else, so we do have a -x left there, but we have nothing to collect it with, right? So that's it. Okay, so for this example, that would simplify that. Let's take a look what else they have thrown at us here. Okay, so now we have a little bit, seems more complicated, but not really, because it's just with brackets, and we've done one of those. So here is an example. So again, the first thing that I do, now I am actually just adding these. Now when you're adding any polynomials together, then all you really have to do is just drop the brackets because there's nothing to do. So this becomes 3r squared minus 4a plus 3a minus r squared. So the brackets just disappear because there is nothing really to do. And now we're going to be looking for some like terms. Okay, we have an r squared here and an r squared here. So 3 minus the 1. So that's 2r squared. Okay, and then this one. So this one is not as complicated. So now we have -4 plus 3, which is -1. And -1, we can write it like this, but we typically will not. Okay, whenever there is just a 1, so you'll just leave it as just an a. So minus a, because there's 1a. And that's it for this one. All right, so let's take a look what else they have thrown at us here. So here's, they have a subtraction, okay, of polynomials. So in this case, so let's see what happens. I'm going to paste that in here. Now, with subtractions, the only thing you have to be careful is the first one, it's not a big deal. So this one, okay, so the brackets will just disappear because there is nothing else. There's actually just a 1 in front there. So there's one of those. But with the subtraction, so be careful, because when you're subtracting, you're going to be subtracting, okay, that entire, in this case it's binomial, it's 2 terms within here. So those 2 terms are separated inside that bracket by that subtraction. Okay, so when you're working with this, so just be careful when you're writing it out. So I like to always say, so this is negative, so -4a, so -4a. And then, this is the tricky part, okay, and it kind of goes into distribution, which is going to be one of the next videos. So here it is negative minus 2b. And remember, so negative and the negative that you have, so that's going to actually turn that to a positive 2b. So now when your brackets are gone, So now in this case, all you have to do is just collect like terms. So I have an a, or minus a, and minus 4a. Okay, so that will become, so negative 5a, and then the negative b plus 2b, that's just going to be plus 1b. So that's going to be that. Okay, and that's simplified. That's as far as you can take it. You can't do anything else. Okay, all right, what else? So I think we had one more. So this one is a little bit longer. Let's copy this through and let's finish off this video with this example. Let's see how we're going to break it down. All right, so again, remember, so your brackets in this case and here, in the first case, nothing happens, as there's only our polynomial inside there. But now with this, you always have to be careful. So because we have a subtraction, so subtracting 4x squared, so this a lot of students remember, but then they forget that they have to do that to each term. So here we have subtraction of negative v cubed, the negative and the negative is now positive v cubed, and finally you have subtracting the plus 2, which is just minus 2. And we can collect our like terms within. So our like terms, let's see, so v cubed, okay, with v cubed here, so that's going to be 11 v cubed, because it's 10 plus the 1. We have now v, there's actually no other v's, so that one just stays the same. The negative, we have negative 8 minus the 2, so that's going to be minus 10. And then we have a lonely negative 4x squared left. And that will be it. Now remember, you can kind of rearrange these. You know, oftentimes what you'll see is, you know, people will put these polynomials with the highest order, okay, in the front, and then the smallest order in the back. It doesn't really matter, okay, it doesn't really change anything for us, but you may be doing that, okay, because this is order of 3 because of the exponent. This is order of 2. This is actually order of 1. Remember, there's an exponent of 1. And this is, okay, just a constant. That's it. All right. So thank you for watching. I hope that you found this video useful with regards to collecting like terms with polynomials and then adding and subtracting them up. Okay. So see you in one of the next videos. Okay. Keep working at it. Cheers. Bye.